Hello, and welcome to Mint and Burn, the academic analysis of blockchain and other technologies in the decentralized digital economy. I'm your host, Kelsey Nabin, and we are tuning in remotely from the RMIT University Blockchain Innovation Hub to bring you interesting guests, publications, and experts to test frontier ideas. This is episode number 4 of Mint and Burn, and today we'll be talking to Mark Miller, Chief Scientist, and Bill Tulloh, Economist at Agoric, on Agoric markets, along with resident experts from the RMIT Blockchain Hub, Professor Jason Potts and Professor Sinclair Davidson. Welcome. So let's start by being very kind to anyone listening to this and explaining what are Agoric markets.
So the original definition back in the Agoric papers that Eric Drexler and I wrote in 1988 is a software system using market mechanisms based on a foundation that provides for the encapsulation and communication of information, access, and resources among objects. So that sentence, obviously, I'm trying to pack a lot in there. So let's unpack it some. The encapsulation and communication is a sort of primitive rights theory that is a way to look at properties that are pretty much universal to modern computation, to modern ways of writing programs, which is that you have these units of organization, objects, modules, applets, etc. You have these units of organization for which I'll generally just be using the term object to refer to all of them. And they have some stuff inside. They have some data that they manipulate that is inside the object, and then they communicate to other objects by making requests, by calling functions, by calling methods, by sending messages. There's various forms, but all of the concrete means by which they make requests of each other, but we can just consider all of them to be requests. And those requests can carry information and can carry access to other objects. So for me, the big aha moment that started me on all of this was back in 1983. I was very excited about object-oriented programming, which was where this notion of encapsulation and communication, sort of this notion of organizing computation around this sort of property rights like notion of ownership and transfer. Uh, that was where it started for me. Is I was interested in that, and I was interested in Hayekian economics, and I was explaining to a friend of mine, Eric Drexler, how excited I was about object-oriented programming, and he said to me, "Oh, that's like Hayek's explanation of what's good about property rights, that society has a massive plan coordination problem, that you have zillions of different agents making plans for the use of various resources, where these plans are formulated in ignorance of each other, and the plans, if they simply happen to conflict in using common resources, can create a nightmarish plan coordination problem. So by dividing up the resources into these separate plots, uh, and such that each owning person or corporation, each owning entity, can make plans exclusively in terms of what they own, knowing that they're not subject to arbitrary conflict of interference from the plans that others have made. Now you've done a lot to reduce the plan coordination problem, and as um, the Austrians here will appreciate, the center of Hayekian economics is the plan coordination problem. How is it that separate plans formulated in ignorance of each other tend to mesh well? And that aha moment where Eric said that I realized that all of that is also the central problem of software engineering. And the big advance of object oriented programming in the early 80s was the rediscovery of essentially that same organizational principle with regard to giving small portions of code exclusive access to particular pieces of data, and then allowing the code to communicate requests and access as they make requests of each other. Um, so that led to the Agoric papers in '88, in which we are trying to paint a unified notion where we, during the intervening years, we translated back and forth several times between our understanding of software engineering and our understanding of economics. And we're trying to help software engineers better understand how to view software economics, software engineering from this Hayekian economic perspective, and how to import into software engineering ideas from economics to help software engineering. And in particular, these were the early days of distributed systems. I was at Xerox PARC. Ethernet had been invented not terribly long before. Distributed systems were just getting started. Uh, and Eric and I realized that the central planning approach to resource allocation in computational systems was not going to scale. It was going to break down. So we wanted to import price mechanisms as well into computation based on this Hayekian bridge between computation and economics to import price mechanisms so that computation resources were allocated with dynamic pricing, processor scheduling, for example, being auctioning off the next time slice, the next slice of what the computer's processor does next, and that this price information would guide each of the participating units of computation to make decisions as if guided by an invisible hand that would serve the utility of the system as a whole. And at this point in the story, Bill comes in.
Thanks, Mark. That's a very elegant kind of summary of the kind of aims and objectives, but also the link between the computer engineering and the economics. Bill, obviously a lot has happened since the 80s. Tell us where you're at in terms of the project.
Yeah, well, as Mark said, I first came into this in 1989, but coming more, Mark came at it from the computation side, where my background was economics, and uh, we back then saw that this was really the future of where things were going, and decided that this was what we wanted to spend our lives doing. And since then, we've been in various ways, both Mark and I, trying to make this happen. And back in the early 90s, we started a company called Agoric that tried to realize this. And this was started even before the World Wide Web days. And, obviously we were a little bit too soon. But now with blockchains coming, we've realized that, we have another chance to realize a lot of the dreams that we saw back then. So we formed a company a couple of years ago called Agoric that is, building a blockchain and trying to realize the vision that we saw back in the 80s.
Phenomenal. And then Sinclair and Jason, you guys have been doing some work with the Agoric team. Tell us a little bit more about what you've been working on.
Well, it was very interesting because I think it was 2017. It might have been maybe 28. I think it was 2017. Jason and I were in at Berkeley at a conference, and we were presenting the ideas of Oliver Williamson in the blockchain space. And by I think pure coincidence, Bill was there and liked our talk and actually came and spoke to us in one of the tea breaks. So we had a long, long chat to Bill, and it turns out Bill is actually a graduate of George Mason University, which is one of our favorite universities, because the economics program there is very different and unique compared to many other economics programs. And the next year, I think 2018, we met up again in New York at Consensus, where Bill introduced us to Mark. And I think we met more or less at a tea time. It was a very quick hello. But the next morning in the breakfast hall, Mark was looking for a place to sit and have his breakfast, and I saw him, and there was a seat next to us. So waved him over, and I said, "Mark, come and sit here." And he came and sat down, and we then discovered our interests in Hayek, and what Mark is calling sort of the Agorics project, we would call the socialist calculation problem. Because how does a centralized economy organize and plan itself? And it can't. And Mark had realized that same problem from a computer science perspective, because he'd also, because I said to Mark, your economics is awesome. Where do you get it from? And he said, oh, Don Lavoie was and the late Don Lavoie is somebody we know well. We've read all his works and what have you, and we ended up just spending hours and hours and hours talking about Hayek and the problems, and it's more or less just taken off from there.
Yeah, what's remarkable about this is just the consilience of having this very general abstract problem of coordinating distributed, a group of people or a group of things coming together to solve a complex coordination problem. And sort of just seeing um, the the types of solutions in completely different fields. And so there's this notion that markets can coordinate through the price mechanism, economizing on information to make distributed plans mesh together is just the sort of miracle of how economies, how decentralized market systems work. And I think Sinclair and myself were just astounded at first, just to realize that you've got exactly the same problem deep in computer science in a field, a million miles away from there, but has the same sort of architectural complexity of bunches of different sort of bits of code needing to coordinate access control to merge and mesh their plans. And I think this is the what we just found absolutely fascinating about this idea of agoric systems, from very, very different perspectives coming together and having the same sort of class of solution. It's been fascinating. And this connection to Hayek, who, this was 60 years ago, 70 years ago, sort of more or less laid out a lot of these core insights, well before we had a digital world to put all that back together again. So, incredible sort of intellectual consilience.
Amazing. So where are you guys at in terms of this idea of computational markets? Like how has it been developing, both in terms of what you've built or what you've tested or launched, and kind of what are the ways that you've watched people engaging with it?
We are building a smart contracting system on top of a distributed object capability system, on top of a blockchain infrastructure. So there's several levels here, but the underlying core theory is very much pervades all of the levels, which is again this encapsulation and communication as a way to coordinate. Uh, the so at Agoric, we're building on our decades of research on how to do language-based, programming language-based support for smart contracting so that the contracts can be written understandably and reliably so that uh, programmers who are not specialists can succeed at writing contracts and can uh, read those contracts and have a good chance at understanding that the contracts mean what they think they mean. What we've seen in the rest of the blockchain world is quite the opposite, is that contracts are incredibly hard to get right, that experts spend tremendous amounts of effort trying to get a contract right. They'll then go and have it audited by other firms that inspect it and try to uh, give it a clean or dirty bill of health. And then we've seen these things get deployed, and due to a bug, hundreds of millions of dollars disappear overnight with no recourse. Now, this will happen in any software system. Bugs happen. We're not going to make bugs not happen. But the key thing was the nature of the bugs. In our research through especially the early 2000s, around my research language, the E language, we had an open source community writing smart contracts in E. E itself was a language, it was a general purpose secure distributed language, but in which the driving use case that the research was around that drove language design was smart contracts. And we figured out how to use it well to write smart contracts. We figured out good patterns. And as we saw a lot of these bugs happening in the blockchain world, so many of us were saying, if they had only been writing the contracts the way we had come to understand how to write them, they wouldn't have had these bugs. So we realized there was an opportunity here. And we're now bringing our understanding of how to support the writing of contracts, both at the language level and at the patterns of organization and at the abstractions, and together with a whole bunch of new innovations around the writing of contracts that improve quite a lot over what we had understood in previous decades. So we're doing that, and I've been focused on building up to the smart contracting layer, assuming that we have an underlying blockchain system that works as a reliable computer. Um, uh, Bill and Jason and Sinclair and the other RMIT people, the RMIT people have been collaborating with Agoric on closing the loop, on bringing the set of market institutions that we are now creating by writing smart contracts on our infrastructure to use those to create the incentive underpinnings for the blockchain, so that our blockchain is itself built on a system of self-stabilizing incentives to create a robust blockchain. And I'll let everybody else talk more about that.
Yeah, that would be great. Feel free to jump in.
So, an important part of what Mark has been talking about is actually defining property rights. When you trade goods and services, what you're actually trading is a vector of property rights, and you can describe the good that's been traded in those attributes of the good. So the Agoric system actually allows you to specify what those goods and what those vectors are, and then trade them and price them, which I think is actually understanding what is going on in a blockchain from a deeply profound economic level, which is something that we certainly don't see that much of in this particular space. So, what Mark and Bill and the others have been doing has been very much focused on getting the underpinnings, the economics, the property right aspects of this correct. And that's what makes this particular project very exciting. But at the same time, when you are building economic infrastructure, which is really what a blockchain is, when you're building this economic infrastructure, you have to get the economic institutions correct. Now, nowadays, people think of economic institutions as, oh, we've got a reserve bank that does money, we've got regulators that do all sorts of other things. But in a blockchain space, you're actually more or less building an economy, and you've got to get that economy fully integrated with the outside world, with other opportunities, in order to get a viable blockchain going. So that's what we've been thinking about, working with, making sure that there are arbitrage opportunities, that there's no artificial pricing, there are no artificial choke points in the system, nothing that would actually make it not work well. And this has actually been very interesting and challenging from an economics perspective, because you've got to think it's the property rights that are important, it's the pricing that's important, it's the opportunities to trade that are important. And that's what you have to build in when you are building a viable blockchain solution to trade opportunities. And that's what we've been doing over the last few years. It's been very, very exciting work.
Incredible. And can you talk about what the Hayekian or the Austrian economics approach to property rights is, to kind of close that loop for us?
Well, how I would think of that is not just Hayekian, but also to a large extent the UCLA approach of people like Armin Elkian and Harold Demsetz, where they also had defined property rights as not relationships between people and goods, but relationships between people and people. What are you trading? You are trading this vector of opportunity, this vector of attributes from one to another. And so it is a case of allowing prices to work in a system, in giving people opportunities to meet and trade, as opposed to specify how that trade is actually going to work out. So the Hayekian approach of not planning an economy, but rather giving market space for people to operate, and then to define what those objects are that people are trading.
Yeah, the other interesting aspect of the Hayekian or the Austrian approach to economics is how it conceives it as a complex, evolving, emergent system. And that notion, I mean, and what this is particularly interesting from the perspective of knowledge. So the Austrian conception is that an economy is made of institutional specifications, of institutions that establish property rights, that create rules, and that those rules relate to particular things, resources, and so on. And that what an economy is doing effectively is it's an emergent rule system that is made of sort of base layer rules that establish property rights. It's made of another layer of rules that establish contracting and exchange and agreements and so on. You've got this stack of this rule system stack. And what is going on then is that economic activity is the is the coordination of people coming together, using those rules to coordinate their activity with other players in the system. But what an economy then is this emergent, evolving rule system that, from a fundamental perspective, is therefore it's not predictable in a sense. You can't plan it, and it's able to sort of create emergent structures, and these emergent structures are the patterns of economic organization. So what the Austrian perspective ends up doing is just being very skeptical of the ability to plan an economy, or skeptical of the ability of high-level policy to come down over the top of it. What that means then is that the what a good economy looks like, what an effective economic institution mechanism looks like, is a well-designed emergent stack of rules that is able then to enable people to come together and do all of the things that they need to do. And this sort of goes back to this notion before about that's the same challenge that you have in a very complex software system, is that it'll start to have these, it's sort of an emergent stack of rules and capabilities that then creates capabilities for things to happen.
Yeah. So a important shift in perspective that happened since we wrote the original papers is, in the original papers we saw this as an analogy between the human world of economics and the internal world of software systems, that both of them can be considered networks of entities making requests of other entities, where the knowledge of the different entities is composed together to bring about greater utilization of knowledge than any one of the entities could have done. But these were just two analogous systems back in the 80s. Today, we look out at the world, and the world is already one in which people make requests of people, people make requests of objects and software, objects make requests of objects within the internals of software engineering, objects make requests of people. Think about workflow systems or an Uber driver. Um, so we've got a complex emergent economy that is where the networks involve both human to human request making and object to object request making and all of the other combinations as well. And when you take this uniform view of it and you can introduce smart contracts in a smooth manner where the players might be programs operating on behalf of people at a variety of levels of abstraction, but the different roles can be occupied by people or software in ways that can change hands over time and still have the emergent structure of the system be this emergent cooperative request making, producing great wealth.
Yeah, I'm really glad you brought that up, actually, Mark. There's another great paper, one of the Agoric ones from the 80s, on this idea of evolutionary computation. And I'm curious, like, how far does this idea go? And it's nice that you draw it into the real world around objects and people making requests. But does AI and automation play into this? Like can you sort of science fiction it for us a bit as well, in terms of not a defined end state because it's evolutionary, but like how this could evolve?
There's a lot of discussion these days in certain circles about AI dangers and about the dangers of superintelligence. And a lot of this discussion around that assumes that the whole issue of human beings um, dealing with the dangers of superintelligence, that these are new things, that superintelligence is something that human beings have not encountered before. In fact, large human organizations are superintelligences. And when you take a look at a lot of this literature, you see that they have many of the same characteristics as the hypothetical new superintelligences we're supposed to be worried about. So our perspective is that the history of political science and institutional economics and all this is already essentially a history of how do we manage these superintelligences so that what they're doing is aligned with human needs. All of the issues in political science of separation of powers, et cetera, all of these things are ways to manage superintelligences by having them be part of a larger network where they're balanced against each other, and the emergent property of the system is still, as much as possible, peaceful and cooperative and not centralizing. So we see the the civilization as a whole is already a superintelligence that's emergent from the intelligence of people and software. And as software gets more intelligent, more of that intelligence will come from AI, but it will still be an organic overall emergence. And to the degree to which we can increase cooperative interactions, we're accelerating that. And a smart contracting fabric that creates risk-free cooperation that can be quite expressive will certainly help accelerate that.
Yeah, interesting. So how do you build security into this system as well? Like you mentioned before that you're using a coding language which is kind of human readable, and part of that is around security. But then you also mentioned that the Agoric smart contracting layer is built on a secure blockchain. I guess what about the other layers here, or how do you try to ensure security in the social and the technical, I guess, of such a complex economic system?
The way I think of security here, I mean, there's lots of different ways you can think about, but I sort of think David Hume put it best when he talks about the stability of possession, its transference by consent, and the performance of promises. And so we're trying to build a system that enforces property rights and the credible commitments that people need in order to create cooperative systems. And in order to build this as an emergent property of the system, you have to build it in these layers of abstraction. And traditionally, we sort of focused, especially Mark, on this smart contract programming layer. But for that to be secure, it needs to run on a secure computational platform. And that's what blockchains give us by allowing us to have credible computers that we can rely on because it's not controlled by one entity, but by the consensus of the group running the blockchain. That gives us a much higher level of security of the underlying system. But that alone is not enough. You also need a programming language that allows the programs running on this blockchain to be able to interact securely. And that's where our object capability architecture that's built into the programming language plays a role. And then on top of that, you need to build the more institutions, that the property rights and exchange mechanisms, what we call our Zoe platform and our ERTP, or electronic rights transfer protocol, that actually allows for the secure transfer of possession by consent. And it's by building up these layers, and it's really taken not just us but this broader community some 30 years to really figure out how to build these layers, that we're finally getting to the point where we can have this level of secure cooperation occurring online.
One of the themes that comes up is there's no such thing as perfect safety, but what you can do is partition risk, is have, if there's some large knot of risk, if you can partition it into um, separate. Let me give an example. Um, so at Agoric, we have an invention that we're calling Zoe that provides a new safety property we call offer safety. Offer safety means that instead of the participants in the contract handing the rights at stake to the contract itself, instead they put the rights into escrow with Zoe and make offers. Um, uh, The problem with giving the rights to the contract itself, which is what everyone was doing, including us until recently, uh, is that if there's a bug in the contract, the rights at stake in the contract are at risk, and that's a lot of risk. And a bug in the contract can thereby uh, cause the entirety of those rights to get lost. Offer safety says at a low level, we can organize a basic quid pro quo mechanism using a fixed amount of code, which is Zoe itself. Zoe holds on to the rights to be reallocated according to the decisions of the contract, but in putting the rights in, each of the players makes an offer, says, in exchange for putting this in, I want these rights back. Zoe guarantees that the only reallocations the contract can do are ones that either refund the rights that were put in or give back what the offerer had asked for in return. When I explained this to the RMIT guys, Jason said, "Oh, that's an Edgeworth box." I said, "What?" Um, uh, But so it turned out that we had come across we had sort of independently reinvented a pattern that was used for analysis in economics. But the key thing here is that a bug in the contract can still do damage, but it's the residual damage after offer safety is taken care of, after the quid pro quo of the basic contract is guaranteed. And that residual damage is often tremendously smaller than the risk you had started with.
Oh, that's fantastic to start to see the interactions between disciplines as well. Sinclair, you're going to jump in?
Well, I was going to say the Zoe is an astounding idea. When Mark explained it, we were sitting in San Francisco, and Mark was at the whiteboard, and he drew it out. Jason and my jaws dropped because one, yes, it is an Edgeworth box, but it's actually a practical application of an idea in economics that. Whenever you would teach it, you always say, "Look, this is just an abstraction, an idea. It never really happens like this, but here it actually was being coded up that people will be trading on it." But the other thing that I can't really overemphasize how exciting it is the offer safety. Um, Whenever I look at blockchain products now and apps and what have you, very often the first thing that springs to my mind is this needs offer safety, and Mark and the Agorics team have come up with this idea that's going to make trading on blockchain so much easier and safer than it has been before. It's an astonishing breakthrough and incredibly exciting. So it's just been wonderful watching it sort of just emerge.
Yeah, it's also interesting just to see. I mean, again, just to go back to this really basic point that what you've got here is an advance in computer science and contract engineering that's providing, reducing, adding security and providing offer safety and so on. And that's a good thing. You think, well, of course we want that. That's like privacy is a good thing, and security and safety. These are all good things, but the point that Mark made before, I think, is incredibly interesting here. Is that from a technical perspective, safety and security and those sort of features are good. But what they do, I mean, from an individual perspective, but what they do is they lower the cost of cooperation, or they lower the risk that comes from cooperation, which then puts this very much into an economics context um, of exchange and an economy is basically an infrastructure for cooperation, and all of the institutions and rules and laws and so on that constitute the order of an economy are technologies that lower the cost of cooperation. And when you have that, that's where wealth and growth and human flourishing comes from. And to sort of see this connection between the computer science, engineering, development of increased security in offer safety and contracting, um, mapping directly to this is how you build an economy, and that connection between you know is completely seamless in this infrastructure. And this is why this notion that what Agoric is computable infrastructure for an economy. It is actually, it's not a metaphor. It's
It's actually happening on the ground. We saw it. We thought, wow, this is like really abstract economic ideas just suddenly coming to life before your eyes and actually being coded up.
It's yeah, it's pretty phenomenal, I guess. Even from when you guys started in the '80s with some of these ideas, you said before the web, and I think, I mean, for a lot of kind of concepts around distributed coordination, there they kind of haven't gone that way. In terms of central planning versus decentralized planning. I'm curious about your perspective towards the role of governance in this economy. Anyone can jump in.
I think that throughout history, people have had all sorts of ideas about governance. There's been a tremendous number of fantasies people have had that if only we could organize society this way, things would be so much better. One of and a lot of those plans have gone wrong, and some of them in going wrong have ended up causing millions of deaths. The one of the things that is exciting in this domain is that you have an inherently nonviolent system within the digital realm. You can have people take their excitement about all sorts of ways to organize things, different forms of democracy, different ways to make decisions, and try them out. And this exploration, many of these will fail. In biology, most mutations are fatal. Likewise, most ideas will turn out to have a flaw in them, but some will succeed brilliantly. And a small number, a bit of progress on discovery of better governance institutions is a tremendously important form of progress. Um, so there's various very interesting experimental ideas like Robin Hanson's futarchy, all sorts of things that can be tried. In the blockchain world right now, there's all sorts of experiments with different forms of governance and voting schemes. So obviously, we're inclined in particular engineering directions in the governance systems we're creating. I'll let others speak to that. But I just really want to emphasize that this sudden ability for people to experiment and try out governance ideas uh, and have that go well and have us all benefit from the ones that turn out to be interesting discoveries is something I'm very, very much looking forward to.
Yeah, I think what's exciting, I think of it in terms of what Eleanor Ostrom calls institutional diversity, and that what platforms like that we're building, based on blockchain is going to allow for this tremendous experimentation in institutional diversity. And what we'll end up with is not, one single best system, but, polycentric systems that sort of nest and interact with each other. And, I think we're just, you're sort of seeing in the DeFi space today this, rapid experimentation and just, new things being tried out, many which fail, but some succeed, happening right now. But I think we're going to continue to see that with, institutional diversities of all sorts of type, not just financial markets.
Yeah, and that rings true to some of those earlier ideas as well around cyberspace and kind of having options of the kind of rules and systems and sort of citizenships, I guess. Interesting you should mention Ostrom. Jason, you've been doing some thinking along those lines.
Yeah, so I think the point that Bill makes there is that just dramatically this suite of technologies, this suite of economic institutions and institutional technologies dramatically lowers the cost of experimentation in the space. And as Mark was saying, when you lower the cost of experimentation, you get more experimentation. When you lower the cost of the risks of cooperation, you get more cooperation. So what we're entering into now is this potential golden age of low-cost experimentation in economic cooperation, and there'll be a lot of mistakes. There'll be a lot of things that don't work out. But the point is that we can test these very quickly. We can figure out the ones that work, and then we can scale those up effectively. So this very much could be one of the we could be very much at the beginning of a golden age of economic growth and prosperity because of these institutional technologies. And I think this key insight that these economic institutions are basically built, economic institutions are just rule systems, but that they can be made of code, and that code can be made safe and secure and scalable is just an incredible. We haven't had this type of breakthrough for a very long time. I mean, this is analogous in a sense to the invention of sort of functioning rule of law and legal systems to create corporate forms that gave us modern capitalism in the first place.
And what else are each of you excited to see this kind of experimentation around?
One of the forms of contracting that was actually the main form in the first smart contracting system that Bill and I and other people at Agoric were involved in. The first smart contracting system was the American Information Exchange, also started in the late 80s. Um, uh, that had a form of smart contracting that we now refer to as the split contract. Uh, and let me explain part of the problems that the split contract addresses before I explain the split contract. In order to automate contracts, the terms that you're automating have to be automatable. But a tremendous amount of what we write into contracts are by their nature fundamentally not automatable. Anytime we talk about um, good faith or best efforts, all of those terms are inherently terms that are about calling in human judgment under dispute. That's what those terms mean in the contract. So in order to automate the parts of contracts that are automatable, to benefit from that, but to still have the kind of rich world of contracting that includes clauses that by their nature are inherently non-automatable, you need to be able to couple the automated part with a natural language expression of the remaining parts to be interpreted by humans under dispute. So a split contract has a pure smart contract component, but one of the moves available to the players in the smart contract is to put the contract into dispute. And the contract as a whole also has this natural language component. And the key thing is that both components were co-negotiated. They were negotiated at the same time as part of one whole. When any of the players puts the contract into dispute, now arbiters, according to the pre-agreed form of arbitration that the contracting parties set up, arbiters would then take a look at the natural language parts and decide how to resolve the dispute. Agoric is not currently building that. We certainly intend to get back to there eventually. It's not our emphasis at the moment, but it's part of our overall vision of how you get into a world of rich, expressive, smart contracting that includes terms that we don't know how to automate, and that in some terms that are inherently non-automatable.
I think what I'm most excited about is really this what we're going to think what I think we're going to see in this sort of exploration of new types of institutions for cooperation. And I think that what the internet and the web have been very good at is connecting people by interest rather than by geography. Wherever you are in the world, you can get together by interests. But now we're making it easier for them to, pool valuable resources, make decisions, allocate those resources, figure out what they want to do together in order to, create wealth for each other. And I think that we'll see just a whole range of institutions that right now are either too costly or that the various legal systems have sort of ossified the choices over the years that we can't do, that we'll start seeing more ephemeral institutions which are just people coming together to create projects that may have very short lifespans, but they can safely pool resources together and make governance decisions around those resources in ways that you just can't today.
Yeah, I think we are on the cusp of a revolution that's going to be like the Industrial Revolution, but I think at bigger scale. The Industrial Revolution completely changed how we live our lives, how we organize ourselves, how and what we did. And the last, say, 200-300 years of the Industrial Revolution, our society has been molded in very particular ways. I think to a large extent, this digital revolution is going to change a lot of the things that we've done and did. and perhaps return some aspects of our lives back to pre-industrial revolution times, except without the poverty and the sickness and all that other stuff. But I kind of think that as human beings, the level of flourishing is going to increase over time. Um, and this is also consistent with a professor at MIT called Thomas Malone's electronic markets hypothesis, where in the late 1980s and early 1990s, he was also talking about the idea that what he called the information technology revolution was going to change our lives and actually lead to a situation whereby we would have more markets operating in our economy than actually sort of large firms operating. Now, it didn't quite work out like that because a lot of the conditions which he identified were there, but what was missing was a trust technology, a mechanism of industrializing trust. And that's what the blockchain has done for us. It has industrialized trust so that we can actually trade with each other in far safer environments, in far safer frameworks than we've had before. And what Mark and Bill and the Agoric people are doing is actually building that profound infrastructure that I think is going to revolutionize how we interact with other human beings and with software and software with humans, as Mark indicated, is going to revolutionize the number of profitable or fruitful interactions we can have with our fellow human that will actually massively expand our growth opportunities and massively expand the economy going forward. So I think there's a bright future as a result of this technology. And our world is going to look very different, but very better than it does right now. So that's what's exciting me.
Yeah, I think one way uh, to see how revolutionary this is that we all talk about the rule of law. And we know that when human societies went from rule by king and decree to various other forms, but moved towards the rule of law, and quite imperfectly, it was a tremendous advance, and it's much of what enabled the growth of the modern world. Um, but it's the rule of law that we have is incredibly imperfect, uh, and it's very, very expensive to make use of it. Um, uh, what we're doing here is we're making law-like systems, the systems that create the benefits of rule of law, uh, accessible to everyone at low cost, and giving everyone a way to interact in an uncorruptible manner with each other, a degree of incorruptibility that's completely unrivaled with regard to any institutional arrangement that human beings had ever been able to create before.
Yeah, and I think the evolutionary nature of that system is kind of one of the most interesting aspects of it that you pointed out earlier. What what is one of the most kind of common or fundamental mistakes or misunderstandings that you come across?
I don't know if for me, if it's so much a mistake or misunderstanding, but I do think there's a sort of different perspective on it that I have from a lot of people here, where I do truly think the fundamental thing that's happening is a revolution in property rights, and it's figuring out how to create property rights in bits. And in some sense, you can look at this as, going back even further than when we started in the 80s, back to the 1960s when you first had timeshare computing, where all of a sudden you had the problem on computers where you had multiple people interacting on this, multiple people, multiple programs interacting together on the same computers. And that's led to sort of the issue of access control. And to put it in sort of Ostrom's terms, the computers, sort of the von Neumann architecture computer is an open access system. And like any open access system, you'll get tragedy of commons unless you come up with some way of managing the resources. And there were really, even back in those early days, two fundamental approaches developed, and one was um, sort of the dominant way now of access control, which is access control lists, which fits the sort of model that Eleanor Ostrom outlines in her book on governing common property, where you define resource boundaries and govern who can enter and determine what rights they have once they enter. But the other system that established there was the capability system, which really followed a private property type system, where it had much finer, more fine-grained division of rights to begin with, and then it was all about how do you combine those rights in ways that you get good cooperative behavior and not bad behavior. And this whole idea of how do you sort of enforce property rights in bits, analogous to the way we've sort of over history have figured out how to enforce property rights in atoms, is the revolution we're in. And blockchain is a huge part of that, but it's just part of that. And we're still probably a long way to go before we truly figure out how to do that.
Yeah. Anyone else want to jump in on that question?
I think not so much a misunderstanding. I think the challenge really around all of the space is increasing user friendliness. So I'm actually when I speak to a lot of people about blockchain, they all think, oh yeah, you're talking about investing in Bitcoin or hodling and all this sort of stuff. Whereas it's actually explained to people that this is a redesign of the underlying economic architecture, the infrastructure that underpins our economy is actually what's going on here. And what I say to people is, there needs to be a lot of user friendliness going on, but also I think it's the Gates quote where it says people overestimate what's going to happen in the next 2 years, but underestimate what's going to happen in the next 10 years. So even though we use the word revolution, this is actually going to be a rapid evolution. I think that's going to occur. That it's certainly going to be changing things. That we will actually see a lot of blockchain infrastructure coming into the way things are done and operated. So it's going to be those things. It's not the cryptocurrencies that are important so much, but it's the actual gains from trade that are going to be made using the underlying technology that's the real game here.
Yeah, I see this as what's interesting about this is that if you think of the 19th and 20th century, were perhaps an explosion of industrial technologies in the world of things, and we got all sorts of magical, incredible things there. But during that entire period, we kind of entered and as the 20th century went on, more and more so, an institutional monoculture. We went from in the Middle Ages and sort of we had a lot of institutional diversity and that was sort of a problem back then. But the nature of the evolution we're going through right now is institutional evolution. It's exploring this enormous falling of the cost of, as Mark was saying, just rule of law, but not just rule of law in this sort of general sense where we think of a nation and its legal system will have rule of law, but the ability for just a community, for a group of people to spin up legal agreements and have those agreements enforced at a low cost means that we're in the same way that the last few hundred years was a period of great industrial technological evolution and dynamics. We're now entering a period of institutional technological and dynamics, and I think that's that's going to be like that's what these technologies bring is this ability to actually dramatically lower not just the cost of building economies but the cost of experimentally building new types of economic infrastructure. And I think that's the thing that I think hasn't quite been fully realized yet, because there's a lot of the challenges around how do we regulate these things, or how do we, what does the politics of all of this look like, is kind of missing the point in a sense, because what this does, these technologies enable, is essentially groups of people to come together and just create their own rule systems to govern their own private communities.
You've each contributed such unique and valuable perspectives to this conversation. I'd love to hear from both Mark and Bill, what should people keep an eye out for, and where can they find you should you wish to be found?
Our company is named Agoric. Our website is agoric.com. I would certainly start there. If you're a programmer, we have periodic hackathons. We just finished one. These are competitions with prizes. We have people write smart contracts on our platform. Some of these are quite innovative. And we support you in getting started using our platform. So I would certainly encourage people to actually start learning how to use our platform from a practical programming point of view.
I would also say that coming up soon, December 12th, Dean Tribble, our CEO, is going to be presenting um, at the Cosmos Interchange. I'm not sure the title of it. The Cosmos Interchain Conversations will be presenting really the first public discussion of our economic design, which the RMIT guys have been so helpful with. So I definitely want to check that out.
Brilliant. Thank you so much to our guests, Mark Miller and Bill Tulloh, and thank you for joining us for this episode of Mint and Burn. You can check out the show notes and get in touch if you have ideas or feedback on the podcast. And if you're interested in more information, visit rmitblockchain.io.